Hey everyone, and welcome. When you think about it, the entire world of computing is really all about one thing: organizing information. Today, we're going to look at two of the most basic but also most powerful tools that programmers use to bring order to all that digital chaos. And it all kicks off with a question you've probably never thought to ask. Seriously, just stop and think about that for a second. You type something, you delete a word, maybe you make something bold, and then click, 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 you can just walk backwards through time. How in the world does your computer keep track of all that? Well, it's not magic. It's actually a really, really simple idea. And this is the perfect way to picture it. Imagine you're washing dishes and you're stacking up the clean plates. The very last plate you put on top of that stack, well, that's going to be the first one you grab when you need one, right? Your computer's undo feature does the exact same thing. Every action you take gets placed on a virtual stack, ready to be lifted right off the top. So let's give this thing its proper name. This is our first tool, the stack. And its entire philosophy, its whole reason for being, is built around that stack of plates. Okay, so in programmer speak, a stack is just a list where everything happens at one single end. We call it the top. If you want to add something, you push it on top. If you want to take something off, you pop it from the top. That's it. You can only ever touch the item at the very top. And this leads to the one rule you have to remember, the stack's golden rule. Last in, first out. Or, as you'll hear all the time, LIFO. Whatever you put in last is always, and I mean always, the very first thing that comes out. Let's really see this in action. To add a new item, we do what's called a push. As you can see, the new thing just gets placed right on top, and the stack gets a little taller. Super simple. And you just keep going. We can push another item on top of that, and another one on top of that. Each time, the newest item becomes the new top of the stack. So if we pushed a 1, then a 2, then a 3, well, 3 is sitting right at the top. All right, so what about taking things off? For that, we use the pop operation. And remember the rule, we can only touch the top. So we pop that top item off, and whatever was underneath it is now the new top. And as we keep popping things off, we're just working our way back down. We're taking them off in the exact reverse order that we put them on. And that, right there, is LIFO. Last in, first out. See? It's that simple. Now, you might be thinking, okay, cool trick with the plates, but what's the big deal? Well, the big deal is that this LIFO behavior is the hidden engine behind some incredibly important things your computer does every second. Let's find out where these stacks are hiding. Stacks are literally everywhere. They're what lets a program run properly by managing function calls. They're how your calculator app actually understands the math problems you type in. They even help a code editor check to see if you've matched up all your parentheses correctly. Pretty important stuff. Now this right here, this is maybe the most important job a stack has. When a program runs a little subtask, like a function, it pushes its current spot onto something called the call stack. It's like leaving a breadcrumb. When that task is done, it just pops the location off the stack and knows exactly where to pick up again. Without this, programs would have no memory, no way to get back to what they were doing. It's absolutely crucial. Stacks are also basically wizards when it comes to translating math. See, we write math one way, but computers need to read it in a different, more straightforward format. A stack helps do that conversion. It kind of acts as a temporary holding area for the math symbols, making sure that the computer follows the right order of operations, doing multiplication before addition, just like you learned in school. Okay, let's try to follow this little dance. The computer reads from left to right. When it sees a number or a letter, like A or B, it just sends it straight to the output. But when it sees a math symbol, like the plus sign, it pushes it onto the stack to just hang out for a bit. Once it gets to the end of a section, like the closing parentheses after A plus B, it pops that plus sign off the stack and adds it to the output. The stack is like a waiting room that makes sure all the operations happen in exactly the right order. So cool. All right, so we've got a handle on the stack. Now let's meet its sibling, the queue. And if the stack was a pile of plates, well, the queue is something you deal with pretty much every single day. That's all it is. A queue is just a line. It's built on a principle we all understand: fairness. The first person to get in the line is the first person to get served. No cutting, no jumping ahead. It's orderly, it's predictable. So let's get into the details. Where the stack had just one active end, the top,
A queue has two, a front and a rear. You add new items to the back of the line, that's called an enqueue, and when it's your turn, you're removed from the front of the line, that's a dequeue. This setup guarantees the rule of first in, first out, or FIFO.
And you better believe this idea of fairness is critical for computers. You know, when you send like 5 documents to your printer, a queue makes sure they print out in the order you sent them. Your computer's operating system uses queues to give every running application a fair shot at using the processor. They're the silent organizers that keep everything running smoothly and in order. So the queue's whole job is to keep things orderly and fair. But of course, programmers have found clever ways to make even this simple idea work even better. Okay, this is actually really clever. A normal queue is just a straight line. But look at the circular queue on the right. By sort of connecting the back of the line to the front, the computer can reuse empty spots without having to shuffle everything in memory. It's a simple little hack that makes things way more efficient. All right, it's time for the main event. We have 2 data structures, 2 totally different rules for keeping order. One's a stack of plates, the other's a checkout line. Let's put them head to head and make it all crystal clear. And this really sums it all up, doesn't it? The stack is all about LIFO, last in, first out, like our plates. All the action, push and pop, happens at one end. The queue is the opposite. It's all about FIFO, first in, first out, just like a line. You add to the back and remove from the front. 2 simple ideas, 2 very different but equally powerful ways to manage data. So the next time you hit that undo button or you wonder why your documents are printing in the right order, you'll know. You'll know about the simple, elegant structures working tirelessly behind the scenes. And it really makes you wonder, right? If so much of our complicated digital world is built on these basic, simple rules of order, what other amazing ideas are out there hiding in plain sight?